Okay, we are live. Welcome, everyone. It is now about 12:30 in the morning where I live in Israel, but that's okay because I'm really excited to talk to all of you about data science in Python. I just want to remind you, anyone who's interested in joining the chat, we have a chat room going. Let me see if I can find a good place to. I keep telling people where it is. I'm not sure if they necessarily know, so I'll put it here in this chat as well. Hopefully everyone can see that. And anyway, there is a bit of a delay. It takes about, I think, 15 seconds from the time that I speak to the time that you actually see it. So from the time I speak to the time that you'll chat back to the time that I speak again, it's like a 30-second delay or something. So don't expect direct, immediate results, but I am looking forward to seeing some questions in the chat room. Oh, I just remember, yeah, I'll do the fixed thing in a little bit. Keep remembering all the different things that happen every webinar. I just mentioned the chat room. This is probably the last time I'll be doing it with Google Hangouts on Air. I just started up trying a company called Crowdcast, and I'll be using them both for webinars and for some online teaching I'm planning to do starting soon. I'll probably be doing some courses, probably some paid courses in the very near future. Oh, there's no audio? There's no audio? Oh, someone just said there's no audio? Well, does no one hear me? Let's see. Looks like it should be. Got audio. Okay. Okay. Good. I always get nervous when someone writes in the chat that they can't hear me, they can't see me. I'm always wondering: is it everyone? Is it just them? It was just them, I think. Anyway, so as I said, next time around I'll be trying Crowdcast, and hopefully that will give us both easier registration, easier immediate chat room, and everything should be okay on that front. So let's talk a little bit about data science. So my plan at this point is to talk for like half an hour, maybe 40 minutes, entertain some questions, hopefully questions that I can answer, and then I will go to bed. And maybe the rest of you will do that as well, depending on what time zone you're in. Because I'm teaching a course, strangely enough, in data science starting in the morning. So I'm going to move stuff around here on my desktop so I can see this here, and this here, and this here. And then I'll share my desktop and a picture of me because people have asked for that in the past. So just give me a moment here. Slide only. I'll also drag the notebook over there as well. Let's not see that thing. All right. There we go. That looks better already. And now let's open up what's it called? Photo Booth. This is the sort of thing that I believe Crowdcast will do automatically. And if not, as I just wrote in the chat, I'll be paying them money so I can yell at them, as opposed to Google and Eventbrite, where I can't really yell at anyone, can I? Because I'm getting it for free. All right, and now I'm going to open up the. How do I do this? I want to have it share my screen. I used to do this all. Oh, here we go. Let's do screen share, and we're going to do desktop, and start it. So now you should, if all goes well, be able to see me and my slides. And then I will keep this here so I can view that. And great, so you should all be able to see me around now. And I'm also going to drag over an IPython notebook, which I'll use for all sorts of demos and cool things. Well, at least demos, hopefully cool things as well. And then we'll switch it back and forth. I know it's sort of annoying if I switch back and forth too much between the slides and the notebook and everything, so I'll try to keep that to a minimum. No, not that. Okay. Anyway, so hopefully now everyone sees some of the slides, some of me here. Let me see if I can move me over a little bit. Let's see. I don't want to blind you all with the light that's behind me. You know what? Let's try turning this on for the. Hold on. There we go, the romantic effect. Okay, so hopefully this is all looking good and sounding good and everything, and you'll be able to see most of what's going on. Okay, so once again, welcome everyone. Let me see, how do I move to the next slide? There we go. So just a few words for those of you who are not familiar with me, although I guess most of you are now, or a growing number of you are on my mailing list, reading my stuff. It's really incredibly gratifying to have so many people join me on these webinars. Register, send me email. I am horribly behind with my email, but everyone who sends me email, I do actually read it. It gives me incredibly warm, fuzzy feelings to hear people around the world. Oh, increase the Zoom. Yeah, I'll get to the Zoom in a little bit. Thanks for mentioning that. So I've been doing development for like 20 years now. Nowadays, a growing amount of my development is in Python. It used to be sort of evenly balanced between Ruby and Python, but I have jumped into Python, I would say whole hog, mostly because I'm doing a huge amount of instruction. Probably about 80% of my time now is spent teaching different companies like Cisco, HP, VMware, EMC, and so forth, going in and giving them courses in how to use Python. I teach other things as well, also Git and PostgreSQL and Ruby. And I guess it was about 6 months ago when I was talking to some people in some of my classes that they said, you know, we're really here not just because we want to learn Python, we want to do data science in Python. I was like, oh, yeah, that's true. This is a growing trend. And the more that I've looked into it, the more I've gotten excited by it, and I've started playing with it more and more. And so the more I've decided that I want to teach data science, and what better way to teach data science than to try it online. So I'm looking forward to getting your feedback. I did a webinar about this about 2 months ago in early December, and I'm really just generally having a blast, especially because I'm able to connect it with a lot of the things that I did in my PhD dissertation analysis. And I'm seeing how much easier some of it would have been if I'd done that. I've done it in Python. So all of you know, this will just be the slides for anyone who wants to see. I guess one of the things that people coming to this webinar might definitely be interested in the site is the site that I run called Daily Tech Video. I'm presumably most or all of you have come here through my blog or my newsletter. Daily Tech Video is something that hopefully is getting some exposure. Basically, I choose a conference video every day, or almost every day, when I'm not too tired or busy. And the idea is these videos are from conferences and super, super useful to be able to learn about a lot of different topics. I actually created it, truth be told, out of total selfishness, because there were all these conferences I was not getting to, all these talks that I wanted to learn from, and I wanted to categorize them by topics so that I could go back to them and learn from them if I ever wanted. So for my selfishness, you guys can all enjoy it. And there's a category there called data science, another one called Python. So you put them together and you've got stuff like what we're doing here. And as many of you know, I've got a book about Python. I've got a book coming out next week about regular expressions, 50 exercises in regular expressions. It's not going to be done yet next week, but the first part will come out. Hopefully you'll get to enjoy it, and I'll be happy to answer questions about that too. But enough about the shameless self-promotion, as they say. So I want to talk to you tonight, about two different things. One is Pandas and one is Matplotlib. And let me give you the sort of the background so far. So Python is incredibly fun, useful, easy to work with. It's a very high-level language, and it supports all sorts of collections. The problem is that when you have a collection in Python, like a list or a dictionary or a tuple, you're pointing to a huge object. Now, day-to-day, we really don't care about that so much, and that's what makes Python such an easy language to work with, because I just have a list of lists or a list of tuples, and I work with that. And okay, so if it consumes a little extra memory, not so terrible. But when you're dealing with large quantities of data, you do care. And so a number of years ago, it's like 15 years ago at least, someone came up with the idea of NumPy. And NumPy, as we saw in the last webinar I did, is this very low-level representation of our data. You get a high-level view. You get to treat it as almost sort of kind of like a list in Python. So it's mutable. You can run also the functions on it. It's vectorized. So if you run a function on it, it actually runs that on everything in the NumPy array. And so NumPy arrays are very powerful, but they're a little low level for some data analysis that you might want to do. And so what we have now is what's known as the NumPy SciPy stack. And you can just sort of keep going up and up and up the stack and doing all sorts of cool stuff. So NumPy, you can definitely do many things with it, and many people do. And in fact, as in preparing for the data science course I'm teaching on Tuesday and Wednesday, I've been playing quite a bit with scikit-learn. And that actually uses NumPy arrays. It does not use Pandas. So what is Pandas, and why do we care, and why do we need to use it? The answer is that Pandas gives us an even higher layer of abstraction. That basically I could use NumPy arrays for everything, but sometimes it's easier to think in terms of something higher level. And it gives us these data structures that let us think in terms of either a higher level array sort of thing, what's known as a series, or even what's known as a data frame. Now, people who are coming from the R world are almost certainly familiar with data frames. I think it's called a frame actually in R. It's been a year and a half since I last used R, so I'm forgetting some of the terminology. But you can think of it almost like a table in SQL. You can think of it like a worksheet in your Excel spreadsheet. And imagine all the things that you can do in a spreadsheet or that you can do in a table in SQL. That's what you can do with a data frame in Pandas. And it basically means that you have this data structure that allows you to manipulate it and count things and do all sorts of cool stuff at this high level from within Python. So Pandas is a library. I think it stands for something, but I can't remember what it is. It's a data analysis library. It's open source under the BSD license. The versioning, for reasons that I cannot understand, are extraordinarily low, right? 0.17 is the latest version that I found, that I've installed. But don't let that fool you. It is in use all over the world by enormous numbers of people. And if there's any trend that I'm seeing in the Python world, it's that it's becoming super popular. I mean, that you probably know, but super popular, especially in terms of data science. There's almost a friendly low-level war going on in the data science world between the R people and the Python people. And speaking as someone who used R for my dissertation analysis, or at least some of it, I can tell you that Python is increasingly eating R's lunch. Not because it has more libraries, because it does not. R still has more libraries. But it seems to me, at least, as someone who's working with people, talking to companies, the critical mass is now behind Python, and we're going to see in the next few years a continued explosion in the number of people using it. And so you have NumPy, you have SciPy, and Pandas is a large part of them. So people are interested in learning how to use Pandas so they can read in their data, analyze it, and then, as we'll see later, also plot it. So what are we going to do with that? Well, what can you do with it? First of all, you can import data from a variety of formats, and we'll see a few examples of that. You can operate parts of that, and you can output some of those parts to files. We're not really going to talk about that at all. And then you can, as I just said, plot it. So, as I said, you can think of Pandas as an Excel within Python. Now, there is a bit of a cultural divide here, and no one talks about it, so I'm going to say it here, and call me totally, utterly wrong. So I came out of the Perl world. Perl was really the first high-level language that I used just after I was graduating, I guess as I was graduating from college more than 20 years ago, shocking as that is for me to say. And so I used Perl for many years, then I gravitated toward Python and Ruby. And the languages have different sort of approaches. And the approach in the Perl and the Ruby world is what we call here, there's more than one way to do it. All right? And the idea is we want to sort of give programmers a lot of flexibility. And in the Python world, it's even stated, if you look at, here, I'll show you here, if we say, if you've never seen this, import this. And the this module in Python, if you load it, gives you the Zen of Python. And the Zen of Python is all these short statements that describe the philosophy of the language and how it has developed and how we're supposed to use it. And one of them is there should be one, and preferably only one, obvious way to do it. And then, of course, they add, that way may not be obvious at first unless you're Dutch. That's, of course, because of Guido, who wrote Python, and is still the head maintainer, as we call the BDFL, the benevolent dictator for life. He gets to make all the decisions. So there's a really strong inclination of Python to say there is one way to do everything, and we're going to give people that. And it seems to me, in my increasing exploration of Pandas, that Pandas has exactly the opposite approach. It's much more of a sort of Perl or Ruby approach, which is we're going to let you try things from lots of different directions because people want to feel, people want to sort of feel their data out in different ways. So you'll see in a number of places here, even tonight when we do this webinar, you'll see there are a number of different ways of doing the same thing in Pandas, and I believe that's on purpose. Whether you want to say that's against the Pythonic way of doing thing or not, I don't know. But believe me, there's so many people using Pandas nowadays that I find it hard to believe that that anyone's going to balk over this. So what is the general workflow with working with Pandas? You're going to read data into a data frame from an external source. You're going to manipulate the data, and then you're going to output it either as a file or as a graph. But before we can understand data frames, we have to understand how to get Pandas and then how to use it, and especially what are called series, which is, you can imagine, a column in a data frame. So I actually sort of resisted this at first when I started working with Pandas, but it's sort of inevitable. You just have to do it because everyone does it. You're going to do an import Pandas to bring in, first of all, you have to install it. And you can install it very easily with pip install Pandas, you're done. Don't forget, by the way, that pip, if you already have a copy of Pandas installed, will not overwrite the previous version. So if you just say pip install Pandas and you already had an old version of Pandas, it won't overwrite it. So you want to say pip install -big U Pandas, and that'll install the latest version from PyPI. And then in your Python program, you could just say import Pandas, but there's so many things you're going to be wanting to do from there. You don't want to just say Pandas this, Pandas this, Pandas this. I mean, it'll seem like a zoo. Anyway, so what you probably want to do is say import Pandas as PD, both because it's convenient and because everyone else does it. And then you'll say PD dot whatever, whatever, whatever. However, almost everyone also then says from Pandas import series and data frame, and that's simply because you're going to be using series and data frames so much, it's a pain to even say PD for that. You don't have to, but mostly everyone does that. Okay, so what is this series? As I said, it's very similar to a NumPy array, but it gives you a higher level of abstraction, lets you play with the indexing in a number of different ways. You get more metadata, but really at the end of the day, I'm going to guess, I haven't checked the implementation, but it seems like it's a wrapper around the NumPy array. So let's create one, right? So here I'm going to show you, actually, you know what? I'm going to move the slides off to the side. I'm just going to do this live, and I will increase the size of the text here for those of you who don't have large enough screens. Haha, that's not the real reason, I know. And by the way, yes, my sense of humor has not improved or changed since the last webinar, for good or for bad. So let's say I do import pandas as PD. I'm going to say from pandas import series and data frame. And we'll talk about data frames in just a little bit. So I want to create a series. So how can I do that? Well, the first way is to just do it with, let's move this over a little bit so you can see part of my face, I guess. Let's do it from just a regular old Python list. So I can say s equals PD, or I can say series. We'll just say 10, 20, 30, 40. Right now, if I look at s, we'll see s is actually looking slightly different than a regular list. In fact, very different. We see it as almost like a table here, where here are the indexes, 0, 1, 2, 3, and here are the actual values, 10, 20, 30, 40. And here's something weird, a D type. Now, if you're used to just plain old Python, then you're not used to thinking about the types of the objects in your list, for instance. You can just point to any Python object. But in the NumPy world, part of the reason that we get this extra speed is because at the lowest level, it's trying to have the smallest crunch number of bits or bytes in there. And so it has to have the same type for everything. If we were to add, let's watch this. If I were to say here, O equals series, and it's 10, 20, 30, A, that will actually work. But look now its D type is object, and so it's going to be a larger data structure, take up more space in memory. Because the way that these arrays work, these NumPy arrays and then series of works, is that they they want to have a real array, like you would have in another programming language, in a compiled language, where all the elements have to be the same size. Okay, so fine, so we've got our series. Let's say we've got S. Now what? What's the big advantage so far? Well, first of all, we can get, as usual with a Python data structure, we can say, give me the index. And here we'll get the index. Look at that. The index is also a piece of like an interesting data structure by itself. Here it's using integers in 64 and 0, 1, 2, 3. All right, and I can say also, what are the values? And I get my array back. That's my NumPy array. And in fact, if I were to say here, what's the type of S values? The NumPy array. So you can see that behind the scenes, we do actually have that NumPy array there. Okay, fine. So what, right? Like, why would we use a series then instead of a NumPy array? Well, here's the cool thing. I can actually say S equals a series. And once again, I'm going to say it's 10, 20, 30, and 40. But now I'm going to add something. I'm going to say index equals A and B, C and D. And now look at my series. Now the indexes are no longer those integers, 0, 1, 2, 3. Rather, they are the letters A, B, C, D. Well, why would we want to do this? Mostly for convenience, because it makes sense. Now I can say, S of A looks like that. I can even say S dot A, and it'll let me do that because I'm moving across by those indexes. If I say S dot index, it shows me now, look at this. My indexes are, and look, they're even Unicode strings. I'm in Python 2 here. So it has to say Unicode string rather than a regular string, and my D type is an object. So you can see it's almost like a NumPy array in and of itself, this index object, and it's storing my indexes there. And this just gives me a lot of convenience that I can play with things. Okay, well, what else can I do? Let's make it a little bigger. Let's say S equals series. So make it a little bigger so that we can play more with it. Series 10, 20, 30, 40, 50, 60, 70. Very exciting, right? Okay, fine. Now I can say, of course, S plus 10, and this is where it behaves like a NumPy array, right? Or S times 2. And once again, it'll multiply by 2. So once again, it's working in a vector fashion. It's doing whatever operation I want across all of that. Okay, fine. What else can I do? Well, I can do another thing that's very common in the NumPy world. I can do what's known as Boolean indexing. And Boolean indexing, you have it in R as well. It's a really wild idea. Where if I say here S of 2, it'll give me back a value. But if I say S, and then I say here, S is greater than, let's say, 50. What do I get back? I get a new series back, right? If I say here, what's the type of this thing? I get a new series back, but the series is restricted from what I had before. It's almost like a slice in basic Python, but I'm doing it with a Boolean operator, and that's why it's called Boolean indexing. And you can get all sorts of crazy stuff here. The thing is, you have to be careful because not every Python operation will work the way you want. For example, let's change my series. S equals series. Let's just make it a little bit 10, 15, 20, 30, 35, 40, 45. Okay, and now let's say I'm only interested in those that are divisible by 10. Okay, so I'm going to say here S, and then what would I normally do? I would say S %10 is not equal to 0, right? Right, and there we go. Oh, I'm sorry. Actually, I want the ones that are divisible by 10. Equals 0. Okay, and you can see that right there. But let's say I want the ones that are not divisible by, not divisible by 10. So normally in Python, I would just do something like this. I would say S modulo 10. Because S modulo 10, it will return the remainder. And if the remainder is non-zero, that's considered true. That's not the way it works here in a series. In a series, if you're applying this Boolean indexing, you must have an expression that includes an equal sign of some sort. So we can say here equals 0 or not equal 0, whatever you want it to be. You just have to be very explicit. And this is true in a number of places here. So you have to sort of get used to some of these things. You have to think about them in new and different ways. So that's basically series. Series is like one column or one row, if you prefer, of information. I prefer to think of it as a column because, as you'll see in a moment, our data frames are sort of built out of these series objects. So series is one column, and you can change the index. Okay, so far so good. Now let's talk about data frames a bit. And you can imagine a data frame is like a bunch of series stuck together. So let's see how we can do that. First of all, data frame is written like this. And I just keep saying, data frame. And whenever I write it, I actually use 2 different words. Why do they use this sort of camel case? I'm not sure. They didn't ask me. Anyway, so let's say I want to create a data frame. The first thing is you can create data frames in a few different ways. You're often not going to do it yourself. You're often going to do it based on reading in information from disk or based on another operation that works on a data frame. So you'll have one data frame, and then you'll run an operation on it, and you'll get back another data frame. But let's see how I could create a data frame. So again, you want to think of the data frame almost like an Excel spreadsheet or a table in a relational database. So I'm going to say here, my data frame equals a data frame. And there are a few different ways you can create it. One is to say that you're going to have a dictionary of lists. What do I mean by that? Well, I'm going to say here, here's my dictionary. And A is going to be 10, 20, 30, 40. And now I'm going to say here, B is, let's say, I don't know, 11, 21, 31, 41. And let's say here, C is going to be list 12, 22, 32, 42. I don't think you get more boring than that. And now let's look at our data frame. And you can see here we have a table. By the way, I'm using the IPython notebook. No one else says the Jupyter notebook, which knows how to work with pandas and knows how to work with all the NumPy stuff. And so it gives you this cool table-looking thing. The only problem with it is you can't really cut and paste it very easily, which is great for people like me making slides, but fine, can't win them all. So here's my data frame, and you can see here that A has 10, 20, 30, 40, B 11, 21, 31, 41, and so forth. Okay, so that's how you could use a dictionary of lists. But you can do it a different way as well. We could say data frame equals data frame. Okay, and now I'm going to say here, now I'm going to create actually a list of dictionaries, strange as that thing seems. So what I'm going to do, I'm going to say here data frame. I'm going to have a list. I'm going to say here A is 10 and B is 20. Well, let's say 11, sorry, and C is 21. That's my first dictionary. My second one is A. It's going to be really long, so I'm not going to do this whole thing. 20, B, 21, C, 31. Let's do one more. I'm going to say here, another dictionary. A is, what did I say, 30. B is 31. C is, that wasn't it at all, but it doesn't really matter, does it? C is 31. Now we look at DF, and we have the same sort of thing. So you can do a list of dictionaries or a dictionary of lists. And it takes a little while to sort of get into this, but I think it's actually pretty clever because it means you can pull out dictionaries. You can use dictionary comprehensions, list comprehensions to create your data in the way that's really interesting to you. Right? I should have done that here, I guess, automatically rather than trying to type and type and type. You can create your data frame in a whole bunch of different ways. Well, wait a second. What if I'm missing one? Let's say I'm going to just get rid of B here. So now I'm going to have ABC, ABC, and AC. what I get is called NaN. NaN is not a number. And that's actually something you need to worry about, because if you're going to do calculations, then not a number is just going to sort of mess things up. It's almost like null. Works differently, but it's almost like null in SQL. So I guess it works closer to that than like none in Python. Right? So if I'm going to say here, df, I think I can do this, max. Yeah. So here I'm going to get like, 30 and 21 and 31. Well, that's pretty good, right? Because I got the maximum number there in each one. If I do min, yeah, we're going to get those. What if I say sum up the numbers? Oh, yes, it does work. Haha. I was under the impression actually that it wouldn't. So there you go. Things I'm still learning. I was pretty sure that you had to actually tell it to ignore not a number, but I guess not. I guess there are other things that you need to do that for. Okay. So what else can I do with this? Well, first of all, we can see here that I have different columns. So I can say df.a, which gives me the A column, or df.b, which gives me the B column. I can also say df A like this, if you prefer. This is almost like JavaScript, right? Where you can say either dot or, I know it's like a dirty word, right, among some people here, but you say either dot A or square brackets A. This is one of those things where I haven't figured out which I actually prefer, and I haven't figured out what the overall Pandas community prefers. But I think you should just try something. I think I'm generally more comfortable with using square brackets just because I think it feels better. Yeah, so someone asked the question, does the impact, average, that's a good place to check. Let's try that. Someone was saying maybe if we check the data frames average, so I think that's mean. No, that seems to work too. Okay, so I was just totally wrong. I know that I've seen where NaN causes problems. I just need to figure out exactly where. But that was a good thought. Anyway, I think I prefer the square brackets, but if you'd like to use the attribute sort of version, go for it. So let's now look at our data here. I can say df describe. And df describe is going to give me what we call descriptive statistics. And it's going to give me a whole bunch of different things about my data frame, which, again, I would do this all the time when I was working with R. So it gives me for the A column, how many items, right? B, how many items, C, how many items, right? You can see here that B only has 2 items, whereas C has 3. Why these are floats and these are integers, I'm not entirely sure. I don't know. Interesting question. It gives me the mean, gives me the standard deviation, gives me the min, it gives me the max, and it gives me the percentiles. If we're going to sort of divide it up that way. So it's kind of useful, and this is one of the first things that you're probably going to want to run on any sort of data that you bring in. Okay, and speaking of bringing in data, how do we bring data in Pandas? And the answer is basically however you want. There is just a ridiculous number of ways to read data, and I'll show you, in fact. So if I say here pd.read, so read is the beginning. It's the start of every method in Pandas that brings in data. And in the IPython notebook, if I start something, I can use tab to get autocomplete and look at all the different ways that you can read data in. Right? Basically, you can read from SQL, so you can read data from a database. You can run a query. You can read from JSON. But it's a little misleading because you can't read rows of JSON. It has to be one JSON object. You can read in from even some formats I've never heard of. By the way, FWF is fixed with field. So if you have a file and you know that everything is like, first 5 columns, second 5 columns, third 5 columns, you can specify that and have it read it in. You can read directly from an Excel spreadsheet. You can read CSV, and that's what we're going to try now. We're going to read from a CSV file. And you can basically read whatever you want in. So let's see. I have a CSV file around here. Hold on just a second. I thought I did. Let's see what I've got. Give me just a moment. No, not that. That's that. Yeah, let's, here, I found a good CSV file. I downloaded, I think it was yesterday or 2 days ago. DBF, someone asked about DBF files. I don't know what DBF files are. If you tell me, I might be able to tell you. My guess is that virtually anything you're going to want to read from, Pandas has a way to read from it. You might need to download something additional from PyPI, but it's almost impossible for me to think of something that it cannot read from in some way, shape, or form. So I'm going to say here, read CSV, and I downloaded the exchange rates between Israel and a bunch of other places. So let's see if I can read this in here. So I'm going to say users, Reuven, downloads, exchange rates, CSV. Okay, so here we go. I'm going to read that in. And here we go. It created a data frame. Oh, DBase. DBase is DBF. I don't know. Does anyone use DBase anymore? I guess so. Anyway, Sorry for the delay between you're asking questions and answering them and me seeing them. Anyway, you can see here we have read CSV, and I've read in the CSV file. And the good news is that I've got a whole lot of information here on exchange rates. The bad news is that, well, these columns weren't really named. Well, why are they not named? I could tell the read CSV to say, well, use the header, right? So I'm going to say the header here is, the first line. Or I could just say, header's first line. That's fine, except that right now those headers are not useful really for us that much. Unfortunately, for whatever reason, it wasn't really readable, and some of it's in Hebrew, and the character conversions didn't work so well. So instead, I'm just going to say, you know what, the heck with it. I'm going to start with line 4. Okay? Well, that still doesn't solve my problem if I need some headers. So I can just say, okay, I'm going to say names equal, and I can specify the headers myself, whatever I want. So I'm going to say here names equals, and then we're going to say this is the date, and then we're going to say this is US dollars, and I think, this is UKP. I have no idea how you say yen, Japanese yen, so I'm just going to say yen, and my apologies to anyone who is from Japan and likes their currency. Okay, so now watch what happens. I've now said read the CSV file. I want you to ignore everything. Treat basically everything through line 4 as headers that you can throw away. And I'm going to specify what headers I'm going to get here. And look at that. I can get even better. I can say here, parse date equals, I think it's 0. I think it's, oh, I knew I was going to mix up. No, sorry. It's like parse. Oh, sorry. There is a way to do it, but I can't remember exactly what the thing is. Let me see if I can find it really, really fast. And if not, then I will send it to you another time. Let's see. I could have sworn it was like parse date. Yeah, parse date equals 0. I'm not sure why it's not working there. Strange. Strange. Anyway, we'll figure it out. Or I'll figure this out and I'll send it in notes afterwards. Anyway, so what's happening here is we're getting all this information, we're getting it day by day, and now we can find out for any particular day what was the exchange rate between the Israeli shekel and a few different things. Okay, well, that's nice and everything, but these read I'll go back to that. These read functions are full of incredible amounts of power. So you can say, for instance, let's say your CSV file has comments in it with hash marks. So you can say, ignore all the lines beginning with hash marks. Let's say you want to remap some of these things. As we see here, you can change the names. Let's say you want to set certain data types. Look at this. It automatically figured out that we have integer, or we had floating point numbers here. And there is a way to parse this as dates. I just got it wrong, even though that's what my slide says I should do. You can parse in dates, and then you have what's known as a time series. And you can actually do slicing based on time. You can say, show me everything from like the 1st of October to the 1st of November. And it will figure out what those dates are, regardless of what order you entered them in. It's really smart in that way. But perhaps the thing that's sort of most impressive and interesting to me is that I can also plot. And not only can I plot, but I can play with things in all sorts of ways. So watch this. I'm going to go here. And first of all, I'm going to add the magic incantation pylab inline. And this is what you tell the IPython notebook, so that if you get an object back that's plottable, and as you might know, when you're in the IPython notebook or any sort of interactive Python, if you give an expression, you give the value of the expression back. So if you get a value back that is plottable, it will now display that plot. So here's what I'm going to do. I'm now going to say, okay, so I'm going to read this into, I'm going to say, I don't know, currencies equals, let's say rates. So now I have a rates variable, and what's the type of rates? Of course, the type of rates is a data frame. And now what I can do is say rates. Watch this. This is like magic, folks. Plot M. And I get a plot. Now, what is it plotting? Well, it's taking all the headers from my data frame, and it's taking all the values from the start to the end. And if I were a little smarter and able to put these tick marks here and set the axes, it would be able to do that. But here I have, for the last, was it 30 days or so? I can't remember if it was 30 days or 3 months. I think 3 months, in fact, all of the different currencies plotted against one another. And reading in it, as you saw, was pretty trivial, and plotting it now is, of course, trivial. Okay, well, let's say I want to play with this a little more, right? Let's say I want to, I don't know, I want to say, oh, I want to see bar graphs instead. Well, that's fine. I can say, rates plot bar. That is going to be kind of ugly looking. So maybe we should only look at it in one place. So let's look at rates again. Let's just look up to the first 10 lines. Now, this is, again, one of those things that Pandas is a very intuitive system to work with, but not necessarily a very Pythonic system to work with. So as we've seen, I can say here rates of, let's say, USD. And I'm going to pull then just the USD column. So you would think that square brackets are working only on columns, but you would be wrong, because if I say here rates up to 5, that slice works on the rows, not on the columns. And so now I'm going to get 5 rows. Now, is this very intuitive? Yes, after you learn how it works. So I can tell you that at first I thought this was just crazy, that the square brackets were used for diametrically opposite things. But now I can tell you I actually think that it's pretty useful and intuitive, but definitely not consistent. So you can see here that I have this. Let's take a look if I say here rates of 0. Oh, no, sorry, rates of 1. Why is it doing that to me? Oh, do I have to do this? Why is it giving me that trouble? All right, fine be that way. Oh, right, that's my problem. Because I'm not using a slice, because I'm using an individual one. So I actually have to say ID LOC of 0. So, oh, there we go. So you can see here, sorry, you can see the syntax is a little confusing. So if I want the slice of a certain set rows, I can use the square brackets. But if I want a particular row, then I have to use LOC, and I say which row that I want. And you can see here that it pulled this out. So let's say I want to compare these. Let's say I want to see how these are in a bar graph. So I can just say plot bar. Oh, don't give me that. Okay, I guess I can't do that. Empty data frame, no numeric data to plot. What are you talking about? Oh, did I? What? Oh, I see. Maybe it's like giving me trouble for that sort of thing. Fine. Thought it would be okay with that, but I guess not. So let me see if I can figure this out really quickly. And if not, we will just, will we do that? Yeah, so I can do that. I think I can also say like that. Yeah, pretty snazzy, eh? Watch this. So I have a row here. I've said LOC of 0. That gives me this row. But I'm not interested in the date. I'm only interested in the numeric values. So I can actually do a slice across the names. And the names here, USD to Euro, and then it ignores the date. Now let's see if I can plot this. Well, yeah, that's not really a useful plot, right? My line plot against these 4 things. So let's make that a bar plot instead. Voila, and now I have, for that particular day in time, I've plotted the 4 currencies against one another. Okay, and I can even, well, let's not go too crazy here, right? So I can pull in all sorts of things and plot them in all sorts of ways. Let me show you one other example of things you can do with things we can do with this, and then maybe we'll take some questions, and then maybe I'll even head off to bed so I can sleep before I start teaching in the morning. So as many of you know, I'm a little obsessed. My latest hobby over the last year and a half has been learning Chinese. And as part of that hobby, I publish a newsletter for people who are learning Chinese. It's like those JavaScript and Python and Ruby newsletters that Peter Cooper and other people produce. So I produced such a newsletter for links to Chinese. And what I did was I actually dumped the data from that, removed the names so that I'm not going to like violate people's privacy and make them hate me. And so I want to load that information up. Now, where did I put it? Oh, I know where I did it. So I'm going to say here, MW, that's Mandarin Weekly. I'm going to say here, read CSV. And I'm going to read it from users. Move in, downloads, mw.csv. Okay. Oh, PD read CSV, sorry. And now if we look at it, I'm going to get information again. I remove the name, so I'm not embarrassed to show this here and have it on YouTube forever. So we have, message number, date added. We can see here, when did they join, basically, when did they join, last follow-up, when did they stop, what IP address were they from. So what's really interesting to me here is the country for now. So what I can do is I can say things like this, because again, it's sort of like a database table. So I can say here, just look for this for a moment, I'm going to look for how, yeah. Watch this. I'm going to say here, MW. MW is Mandarin Weekly. That's all of my subscribers. So far, so good. I could say MW group by, right? If you're familiar with SQL, it's going to sound pretty familiar. Group by country. And then what do we do in SQL once we group by? That's right, we then count. And here we have now our table with accounts of how many people are there per country. Now, that might not seem so exciting, but I think it's pretty cool that you can read in this CSV and do these calculations pretty much effortlessly, right? In these 2 lines of code, I was able to read in data that I got from somewhere, and it was a reliable source, presumably, and I was able to do this count. Okay, well, maybe I want to like not have all these columns, and that's sort of a function of just how the counting works. So maybe we want to like, let's just get country from there, right? And now I have a table here of all the countries that people are subscribed to me from, all the locations, and the numbers. So I could, if I really wanted to, right, just do a plot. Let's do a plot and a bar. Now it's going to be kind of ugly, right? It's going to show all these names in very, very, very small print. So maybe what I really want to do now is just get the, let's first of all sort them. So here I'm going to count them, and then, but I can't actually count if I restrict it already. Now I'm going to say sort values. I'm going to say by equals country. And what does it give me? Problem here, not sort of country. Hold on a second. Count sort values by equals country. Should work, I believe. Fine, let's do something else. No, why is it giving me that? All right, let's try this again. I group by that count sort values by equals country. Okay, I don't know why I'm getting this trouble, so let's try this once more. If that doesn't work, fine. Let's see, I had it actually before. I was just double checking things, so let me pull that up. See how I actually managed to calculate it. Yeah. All right, so that's, sorry, just scrolled the wrong way. Okay, this should work, I thought, but let's find, let's try it again. Group by, count, so let's try sort values by equals, let's say misc. Yeah, that works. So the reason was, I guess, I can't use the same thing in my group by and in my sort. Okay, sorry about that, guys. All right, so now you can see that it's sorted, actually, is it sorted? Yeah, it's sorted by misc, which is 0, 0, 0, 0, 0. And then going up to something else. Actually, that was exactly the one I should not sort on because that actually doesn't have anything. So let's try again. Let's try IP address. Yeah, there we go. That's much better. And you can see it's sorting here. We have one. So I have one person from Iceland, one person from Lithuania, one person from Ireland, and on and on. But what if I want to sort in decreasing order? Then I say here, ascending equals false. And now it's in descending order. So I've now taken this data from a CSV file. I've turned it into a data frame. I've counted how many people are in each country, and I've sorted it. And then what I can do, of course, is just cut it off. I can say, well, I'm only interested in the first 10, right? And now I've got the top 10 there. And now I can, of course, take that top 10, and I've got a data frame back. So what can I do with a data frame? Plot a bar graph. Okay, well, it gave me, like, I don't need this legend here, which is, like, totally in the way and annoying. But other than that, other than the legend, which I don't remember exactly how to turn off, you can see that basically I was able to get the bars of all the places people are from. And I just definitely want to get rid of that. Hold on a second. Let's do this. Let's say here, IP address. Yeah, that's a little better, huh? So what did I do? I started with, let's just walk through this. I start with my data frame. I group the data frame by country, which gives me all the columns of the data frame in that grouping, but it's actually a grouping object. It's waiting for us to run something on it. It's a lazy loading object. We then run count on it, which means that we figure out how many per thing. I then say to sort that resulting object by the IP address. I say ascending false. Then we take the top 10. Now, as of this point, I have a data frame. So I'm grabbing the top 10 rows from there. And then I say, well, I'm only interested in one column. And I plot that one column, and we get that here. And so now I can see that I have, 130-something people in the United States. The next highest is the United Kingdom. Next highest is Australia, and so on and so forth. So basically what I was able to do in 2 lines of code was read in information and plot it pretty much effortlessly. Now, you might say, yeah, but you messed up a lot along the way. Perhaps. But Part of that is just because I'm still getting used to some of these data structures, and part of it is because I'm just that way. That's just me. And part of it is also I really am enjoying the playing with and exploring different options and the different angles you can get to things from using pandas and using these tools. I think that's basically what I wanted to give you in this webinar here, sort of a brief overview of the sorts of things you can do. But as you can see, you can do amazing things with reading data in. You read it into either a series or more typically a data frame. And by the way, why did I tell you about series? Because each column of a data frame is a series. You can create a data frame from multiple series. So once you pull out a column, then all the things we showed about series are still true. So what will happen then is you will sort of pull your data into a data frame. You will manipulate in different ways, whether it's sorting, whether it's pulling things off with Boolean indexing, whether it's calculating things on it. You can also, of course, add data frames together. You can join them just as you could join two database tables. And I think I'll talk about that next webinar, how to join them in different ways and pull out different reports in that way. Anyway, it's incredibly fun and satisfying. And I'll also add that this whole data science thing is growing by leaps and bounds. It's unbelievable how many people are doing it and how many people are getting into it. And the amount of stuff, the amount of data you can pull offline trivially easily is astonishing. There are a bunch of good podcasts about data science that I've been listening to over the last few months. One of them is called Data Stories, and they interview people who have really interesting stories about stuff they've done with data science. There's just this guy on, I cannot remember his name, Ben, something with a W, where he lives in New York, and he runs this site called iQuant New York, where he goes to the city data, which they provide in spades, and he goes and retrieves all sorts of amazingly cool stuff out of the city archives and then does investigations about what is life like in New York. And the most interesting story he had, and I'm probably like stealing his thunder here by retelling it, is he figured out which areas of New York are most expensive to park in. Like, where do people get the most parking tickets? So he knows like where you're likely and not likely to get parking tickets. Oh, it's called, the name of the podcast is Data Stories. There are a few amazing data science podcasts. Also, there's one called Talk Python to Me, which is about Python. And at the end of 2015, they had a joint podcast with, I can't remember. There was a data science podcast that they had a joint broadcast with, where they talked about the top data science stories of 2015. And that was also entertaining and interesting. But really, the amount of data you can now get online for perusal and analysis is just unbelievable and astonishing. You have UC Irvine has an archive of, let's see if I can just find it here, like uci.edu. No, here we go. Here we go. Machine learning repository. And they just have incredible numbers of data sets, mostly for machine learning, but not just. And you just go anywhere. Basically, just yesterday or 2 days ago, I decided I wanted to look up flight data. So I searched online for flight data sets, and I found all sorts of stuff. You've got music data sets. If you're interested in a subject, the odds are pretty good that there's a data set you can at least, partially derivative, thank you, Mark. The odds are pretty good that you can find an amazing data set to download and play with and install and explore and maybe even find something truly astonishing. Anyway, I'd be delighted to answer questions if I can. If not, I'll see that as homework for myself to get back to you on. I hope this was useful and interesting and somewhat informative to get you into the sort of the mood and to show you that once you start to understand these data structures, really everything flows from there. I think for me, the big hurdle in starting to use pandas and starting to do a lot of this data science stuff was actually understanding the data structures, because they're not your standard sorts of Python data structures if you're used to those. That said, if you're coming from outside the Python world, if you're sort of new, there is a bit of a learning curve here, because you're learning Python and you're learning these data structures that are built on others, and then you have to learn sort of the exceptions. But it's pretty friendly, and the amount of documentation is unbelievable. So if there are questions or comments, I would be happy to entertain them, or answer them, not just entertain them. And if not, then I just really appreciate everyone coming and joining me. And hopefully this was useful. Yes, they do seem to be similar to R. So it's interesting. So Jim mentions in the chat, they seem to be similar to R. That's true. Absolutely 100% true. I don't have more to add to that, except that people coming from the R world, I think, will feel very comfortable using pandas. And I'm not sure if that's because it's just sort of I'm not sure if Pandas was designed this way because it seemed natural or because it was similar to R or both. But there's a lot of overlap there, and that may lead to more and more libraries being ported from R to Python and to Pandas. I'll tell you, when I was doing my dissertation and I did some social network analysis, I asked the guy who was helping me do the analysis whether I should use Python, because I'd heard that there was a social network analysis library. He said, no, it's not mature, it's not fast. You should definitely use R. But again, that was all of probably like a year and a half, 2 years ago. I'm sure that by now things have caught up to some degree at least. Yeah, so someone asked, David asks, should I worry about not a number? The answer is yes. You should definitely worry about not a number, and you should worry about it in a few different ways. First of all, it'll mess up your calculations for sure, even though I demonstrated that was not the case. But if I say here, like import numpy as np, right, and then I say, n equals np, array of 10, 20, 30, and n, right, np, and 40 and 50, right? So if I say here n plus 10, right, so the nan will stay there. And if I say here n, let's say sum, it'll give me nan, right? So this is what I was expecting in Pandas. I'm not sure exactly why the series didn't give me that. I have to look for it. But you're often, very, very often, going to want to go through your data and remove the nans from it so that you don't, I'm sure that's how you're supposed to pronounce the nans from it, so you don't have those not a numbers that are messing up your calculations. Because clearly what you want to do here is say not just the sum, but the sum minus the nans. And now, of course, I have to remember, we have to say here, it's like n, and I'm gonna mess this up. NP is nan of n equals false. I think that's the way you do it. Yeah, right. And now that I've used that Boolean indexing, now I can say sum. Now it'll give me the sum because it's removed the nan from there. And you have to really do that quite a bit whenever you're working with nans. Skylar mentions, do I have any good data science stat books for reference? There are a few put up by O'Reilly. So I've been reading like whatever I can on the subject. So I'll tell you, there are a few from O'Reilly. Let me see if I can find a few of them. One of them is called Doing Data Science, right, by Kathy O'Neill and Rachel Schutt. I really like it. Kathy O'Neill, by the way, is a panelist on the Slate Money podcast, which I love. And she is funny and clever. So I was very happy to read her book, which is still good, but not quite as funny as clever as she is on the podcast. There's one called the Python Data Science Handbook, Python Data Science Handbook, yes, which is an early release, but it's still amazing. And it's like 742 pages long. Definitely recommend it. Both of these, I've been going through these, and there's another one, which I can't remember what it is, but I have a talk from him. I can't remember his name either, but I have a talk from him on the Daily Tech Video site. Someone mentioned packet books. I'll tell you, I keep getting packet books. I keep not looking at them as much as I really should, and I'm positive that they're good, and I'm positive that I'm just sort of a slave to O'Reilly. But I'm going to be looking at a bunch of those packet books, not just for data science, but also for a related field, like part of data science, which is machine learning. And there they have a whole bunch of books that I've been looking at as well. I would say if you look at these two books for starters, that will give you like enough starting information and then some. And there's an incredible amount of information online. Oh, excellent. Thank you for the podcast link to the data stores. More questions or comments? These are great. And it does look like nan behaves like 0 in Pandas. I'll tell you, I have to check into that because I didn't think that it did. Moreover, I know that if you're using scikit-learn, that you definitely need to deal with nan. Oh, good question. Will the data science handbook replace data analysis with Python? So first of all, I'm glad that you reminded me about the data analysis with Python. So I've been going through that over the last few months to really make sure that I understand, what was I going to say? I really understand Pandas and how it works. The good news with data analysis with Python is it's written by the author of Pandas, and it's really thorough, and it goes through things great. The only problem is it's a few years old, and some of the API calls they have there are out of date, which means that you may need to wrestle a little bit with your Pandas installation or just with the function calls to make sure that you are doing the right thing. But if you're willing to deal with a little bit of backward incompatibility, then I'd say it's definitely worth getting the data analysis with Python. Data Science Handbook sort of goes one step further. Data Science Handbook says, let's talk about NumPy, Pandas, and then scikit-learn, and then what do you do with this? So I would say they don't replace one another. I would start with maybe with data analysis with Python, play with Pandas for a bit, and then move on to the Data Science Handbook where it'll be good. I'll also tell you, I mean, we'll talk about this maybe in another podcast, in another webinar or two, but I'm starting to get into, as I said, some of the machine learning stuff, which is surprisingly easy. I was terrified of having to learn it, but maybe it's just because I took a bunch of semesters of statistics, so it's not so bad. But there's this thing called like Jumpstart Machine Learning. Oh my God, it's like very, very dense, but very good. What Python installation would you recommend? And I must admit, I know nothing about this Anaconda. I keep seeing it mentioned. I feel like an idiot and very, very foolish for not knowing about it. I believe Anaconda is a pre-compiled, is a version of Python that you can install that has everything already with it, so that you don't need to install Python and then NumPy and SciPy and Pandas and scikit-learn and all that stuff. You just get it all at once. There's something similar called Python XY, which I've seen in the past. I'll tell you, my inclination is just to install the stuff sort of raw and like by myself, but that's because I'm like developer and I'm installing stuff from PyPI all the time. I would not, someone here says that Anaconda is amazing. I will totally believe you, and I will believe that once I see it, I will start recommending it to my students instead of having them install everything on their own. So I've got to look into that. Thanks for mentioning it. It's worth looking at. I would say, again, if you're a Python developer who is looking into data science, then I would still recommend probably installing stuff with pip, just because you're going to be used to that, and why mess with other things. But if you're not so strong with it, Anaconda is almost certainly worth looking into. Yeah, it has a lot of data analysis bundled with Python, James says. And here we go, import Python. Someone also mentions in terms of the importing is nan. Yeah. So it looks like there's something weird with nan going on here that I better figure out before I start teaching the subject in the morning, huh? More questions or comments? These are great. Okay. So I'll give you guys another few seconds. How could I have forgotten this? So I finished last week, just a few days ago, for those of you who are still watching this, and I'll mention this in the email I sent out also. So I mentioned that I released last year an ebook called Practice Makes Python with 50 exercises to improve your Python. It has nothing to do with data science except for the Python part. Anyway, I did screencasts for each of the 50 exercises. It took way longer than I expected to do those screencasts. It turns out I did like 5 hours of video, way more than I ever expected, which explained why it took so long to do it. In any event, I released those videos a few days ago, and I am giving a big discount and a coupon code to anyone who buys the video version of the book, that is, say, the book plus the video packages. So I'll mention that in the email that I'll send after this webinar, but I'm giving people like another 2-3 days to use that coupon and get a big discount on it. It does cost something, but like for the number of minutes of Python and me, hopefully it's worthwhile and useful, and will help you with your Python programming as well. And my plans are, not after I do the regular expression book, to do similar screencasts. Then I'm working on a book about technical training, and then I might even do a book about data science, also exercises to practice. But suggestions, comments, questions are always, always welcome. You can email me, you can tweet me. I love hearing from people. Thank you, everyone, for joining me, and I look forward to seeing you hopefully another month or so at my next webinar. Anyway, have a good night or good day wherever you are, and all the best. I'm going to shut this off now, and we will talk soon. And thanks again for joining me.